This is an independent project for the ME 3210 course at Georgia Institute of Technology for Dr. Rashidi. This video covers the design prompt, a design proposal, concept graphics developed in SOLIDWORKS, manufacturing processes, material use, and product analysis. The project task is to improve a product that I use and focus on developing an aspect of its design, like human factors, ergonomics, and ease of use. An issue that I frequently have is that I buy decorative enamel pins, which are often expensive, for my bags to commemorate trips that I took with my loved ones or just any experience that I want to remember. And these pins often fall off throughout my day, and now I've lost a sentimental token. I've always wished that pins were built to be better at securing to bags. Because I've lost so many pins, I've stopped buying new ones and have taken the ones that remained on my bag off in fear of losing them. Going to the drawing board will help us better understand the overall concept. A solution would have to overcome a few situations. Pins often fall off of bags from collisions with other objects, rubbing or friction, or shaking and/or vibrations. The solution in mind for this project is to replace the backing of your standard pin base with a rotation mechanism that once the pin is threaded through the fabric or the cloth or material of the backpack, will then rotate over the pin and lock it in place to prevent it from leaving its locked position. After modeling and going through a few prototypes in SOLIDWORKS, the final version of the solution, which for this project will be called pinned, looks like this. So how does the new pin differ from what's already out on the market? Here we have a pin of Buzz, the yellow jacket mascot. The back of the pin exhibits your typical pin or enamel pin backing. You have a safety pin-like rod that hooks into whatever fabric or thread that the backpack is made out of, or whatever material you're attaching this to is made out of. And this pin, once threaded through the material, comes back out and gets secured under this loop that juts out. The issue here is that nothing prevents a downward force from pushing this pin under this loop and back out, which would then look like this configuration. And here you would have a pin that falls off of your backpack. The pinned product solution is to replace the fastening mechanism of a traditional pin. And how that's done is by using an eye screw that juts out and holds this pin guard. It also facilitates the rotation of the pin guard. This pin guard is 3D printed, and the curvature here prevents the rod from being knocked loose or moving out of place. How this would work is you rotate the guard out of the way, you lift the rod, you thread this rod through whatever material this pin is attaching to. You then close the rod again, and then you simply rotate this and lock it into place. Here, you do not have the same chances of this pin falling off of the bag as you would from the traditional enamel pin base. And any possible way that would happen is from material being worn out here that would increase the fit tolerance between the eye screw and the pin guard. The friction between these two parts and the tolerances, or the low tolerance between these two parts, it is what prevents this part from rotating easily. And this is how we ensure that the pin would stay on the bag. Here is a schematic of the pinned product. Here mainly we're just showing that fitting in this new fastening mechanism does not increase or change the size of a standard pin. We're able to fit all of this in your standard pin, so you're not going to have a bulkier decorative attachment to your bag. A diameter of roughly 1 inch and a thickness of 1/4 inch. And all of the parts here, they're pretty lightweight parts. You have a brass plated aluminum base, which is all of this yellow here. And then the rod would be 3003 aluminum, just a little bit stronger aluminum for the pinning process, and the fact that this has to thread through material and fabric, that needs to be addressed with this material. And then you have a flush mount press fit nut. This is 18/8 stainless steel. And the pin guard that rotates from the previous video, that is simply 3D printed ABS material. ABS, so that there is, again, a little bit more strength than more cosmetic 3D printed products. And then this eye loop or eye screw that facilitates the rotation of the pin guard. This is a modified machine screw style hanger made out of zinc plated steel. Most of the expenses might come from this part because it would have to be machined down to a short enough length to fit on this pin. Here are some pros and cons of the pinned product. To start with the pros, this is a standard pin size. We are not increasing the overall size to fit this extra mechanism. Another pro is that it features simple geometry. You don't have any shapes or features that are too complicated in shape. And the last pro is that there is no interference with the original function of threading the rod through the backpack or material that the pin is attaching to. Some of the cons are that the custom hardware costs might be expensive because the eye screw that facilitates the rotation of the rotating pin guard needs to be machined down to fit into the pin without jutting out. Another con is that a lot of these parts are pretty small, so that might make assembly and even manufacturing more difficult. And the last con is that there's a lot of aluminum in this product, and that results in an overall lightweight pin. And although usually that is a good thing, a lot of people like the weight with heavier pins, and for some people it does say something about the quality of the product. Finally, these are the references that were used for the project. Thank you.